Okay, so here's a problem similar to one that you have in your homework. And you're given this isotope, and this is accurate information. So that 226Ra, that refers to a substance in chemistry, and the half-life is 1,599 years. And we have to find our initial quantity. So first, since we're talking about half-life, we know we're referring to our exponential decay model. And initial quantity would be our A, so we're actually looking for A. And we're also given that after 1,000 years, our substance is 2 grams. So again, remember, in this ordered pair, X represents your time, which could be in years, days, minutes. It just depends on what the substance is or what you're talking about. And Y represents the amount present after decay of A. So that's referring to that constant A right here. Okay, so we're going to try to use our information to figure out what we need to do in order to solve for our initial quantity. So we're given that the half-life of the initial amount is 1,599 years. Okay, so half of that amount, so 1,599 years, it will have its half-life of that substance. So to represent that, X is, of course, represent our time. So we have 1,599 or 1,599, and Y would be half of our original amount, A. So it's similar to the first video. So if you didn't go to the first video, go back to the first video and look how I did that example over again. Okay, and we're also given, let's write down all the information we're given. We're also given that after 1,000 years, we're left with 2 grams of that substance. So that's an exact amount. So it's not 2% of the substance, it's 2 grams. It's that actual amount. So we have these 2 points, if you want to look at them as points, these 2 ordered pairs that we can put into our equation and find our information. So of course we need to first find out what B is, and then once we find out what B is, we can go ahead and solve for A, which is our initial amount, which is what they've asked us. Okay, so let's start off with the 1,599 1/2 A. And again, this is Y equals A e to the negative bx. So this is going to be 1/2 A equals A times e to the negative, I'll put the coefficient first, 1,599 B. And I didn't have to put parentheses there. Alright, so our A's go away, because that's just a constant, and we're left with 1/2 equals e to the negative 1,599b. And so we take the natural log on both sides. And because I don't want to make this video too long, I'm going to skip some calculations, but make sure you check to see if you get the same solution. And so once you finish solving for this, your B is going to be, you're going to approximate it, and in this case, it's 0.000433. And because I had those 3 zeros in front, that's why I extended it out 3 more digits, just to get a more accurate approximation. You could have rounded it off to 0.00043. I wouldn't just round it off to 0.0004 because you just want to get a pretty good estimation of it. So that's what you should have for B. Now, if we go back, so we have Y equals A times e to the negative 0.000433x. And so now this is where we will use our other point that we were given, that after 1,000 years, we'll have 2 grams of the substance left. So that's 2 equals A. 2 equals A times e to the negative 0.000433 times 1,000. And now, so this right here, let me highlight in different color. This is just a number. It looks crazy, but it's just a number. And actually, so A is going to be equal to, actually I'm going to, if you multiply that by 1,000, you'll have 2 over e to the point, let's see, negative 0.433. Okay, or you can just do it, calculate it all together at the end, but you still will get the same answer. So once you do this, your a should equal about 3.08. Okay, and so that's how you do that problem. Sometimes you'll be missing a half-life and given the other two expressions, or they mix them up sometimes, so I'm not for sure which ones you have on your homework, but I know this was one similar, so hopefully this helped you guys out, and you can email me if you have any questions.